This is the first of videos on gravity, following the series Fundamentals of Physics. The last, number 7 video on the fundamentals, I mentioned that energy can be represented by the separation between bodies in different dimensions, and particularly that the total energy can be represented by the vector sum of all the separation in all dimensions. I'm going to use this to explain how gravity works. I'm not going to go into a lot of details as to the calculations or the reasons why I believe this is the way gravity works, but to explain the theory in outline, and then in later videos give more information. I'm going to take the Earth and the Moon as an example, because there's general agreement that the Moon started life from the Earth as a result of a collision with an asteroid, and there's general, I'm sure, acceptance that it's an approximately circular orbit now, and I want to explain how it got into that, how it became into orbit and why it became circular. So I'm going to start by describing how the first orbit of the Moon. The Earth was apparently struck by some body with about 1/30th of the Earth's mass, 1/3 of the diameter, and I believe actually that came from the Sun as a would-be planet, but that's not important. The Earth was struck by the asteroid, and as a result, the asteroid, or part of the asteroid and part of the Earth, went off into space and for a certain distance, and then returned and started really what was a highly elliptical orbit. That's, I think, pretty obvious. I don't see how anything else could have happened. How did this become a circular orbit now, with the Moon going around the Earth approximately 4.5 billion years after the initial orbit? How did this happen? Well, to explain this, I'm going to use the dimensional theory, in which I'm going to specify that the initial orbit began with a single space orbit, because the Moon went more or less straight up from the Earth in one dimension of space. Well, there's not room on the board for more than one dimension of space, because I want to include here another orbit that I know, or rather dimension, that I call the X dimension. Now, the X dimension is a dimension that accounts for kinetic energy. As the Moon went up, leaving the Earth at just under the escape velocity, I think that's pretty obvious. Escape velocity now is about 25,000 miles an hour, and we have to assume it was about the same at this time, which was about 4.5 billion years ago. So it would have left somewhere around, say, 24,700, 800, something like that, close to the escape velocity. It would have gone up, it would eventually have stopped due to gravity, would have returned, and if it had gone up from this side, it would have returned to the other side and just scraped the Earth and continued in a very eccentric elliptical orbit. For reasons I'll give on another occasion, I believe that the period was much shorter than it is now, just a few days, so it would have gone up and come back maybe a day or two later, rather than the 2 weeks later, which it would be if it had its present period of just under 28 days. Now, the reason for this I'll explain on another occasion. Then, the reason why it came back and why gravity worked is as follows. The space separation clearly is associated with potential energy. But what about the kinetic energy, which at this point would have been high? The potential energy would have been low because it was at the Earth's surface. Here the potential energy would be high, the kinetic energy would be zero if it were a very, very elliptical, eccentric ellipse. The moon would have virtually stopped at the top of the apex of that first orbit, and therefore its kinetic energy would be zero. So I'm using X to represent the kinetic energy. So at this point, the moon would have been here, not only in space, which is obvious, but also it would have been at the origin of the X dimension, because its kinetic energy would be next to zero. So this distance then represents the potential energy at that point, and it's almost its entire energy. So I'm calling that the energy equivalent length. It's the distance between two bodies when the energy is all potential, and therefore all in the length separation in space. So that represents to me the total energy between the Earth and the Moon, and my theory specifies that the total energy cannot change for two bodies that are not in contact, and that the Earth's energy now is the same as it was at this point, barring small changes due to asteroids striking and so on. Now, if that is so, then when it left the Earth and its potential energy was very small, then its energy would have been entirely kinetic, and the equivalent separation for that is the same as this distance. So I'm saying that the Moon was here in the X dimension at the time when it left the Earth and went up into space. So I'm saying that the X dimension has a displacement initially equal to its displacement when it was at the apex of its trajectory in space. Now, how did I get from here to here? Well, it had an upward momentum. And you may remember I said that I think that gravity is caused by the conservation of energy and momentum. We conserve energy by the total distance between the Moon and the Earth remaining constant, which means it has to follow a path like this. So that the total distance, which is the vector sum of both the X and Y dimensions, is constant. At this point, it was traveling in this direction, so it would be traveling in orbit, as it were, around what I call the energy circle or the energy shell, at a velocity close to the speed escape velocity. I would estimate somewhere around 24,000, say 700 or so. I have said 900 in earlier writings, but my present calculations make it a little lower. Somewhere close to the escape velocity. And that this momentum would keep it going at the same velocity all the way around. The period initially would have been small. That again, I won't explain the calculation for that. But it would have had a period of about a total period of somewhere between 3 to 5 days for a whole cycle, which is much less than it is now, 27.3 days. That's its initial path. And in visible space, it would have gone up and down, leaving one side of the Earth coming down on the other side, assuming that the Earth didn't spin, up and down, and it would perform a very eccentric elliptical orbit with that short period for some time. But it would, in terms of astronomical time, after a short period, which may be a few thousand or a million years, broaden into the present circular orbit, which I'll draw now. And I won't explain how, at the moment, how it changes that orbit, but there's an explanation for this. But now it is, the Earth is here. The orbit now is smaller, about 2/3 the size of the initial elliptical maximum radius. It's now about 237,000 miles radius, and its period is about 27.3 days. Now, what then does that X dimension, what part does it play now? I'm going to draw that, but I'm going to have to show two drawings because we're now allowing for 2 dimensions of space because it's in a circular orbit, plus the one for the X. So I'm going to show you a spherical energy shell in which, looking at it from the 2 dimensions of space, the moon is going around the Earth like this, and this is R1 if you like, and R2. These are the 2 space dimensions, and that's what we see. We don't see this. This is the energy shell. It's on the surface of a 3-dimensional energy shell, like a sphere. So I'm going to show you now the view from the side, showing you just one space dimension and the X dimension. And the X dimension represents kinetic energy, and it has kinetic energy. We know that it's traveling at just over 2,000 miles an hour. So there's kinetic energy there, but it's not seen in this diagram because this shows only the fairly constant potential energy. This, looked at from the side here, you see the circular orbit here, with the moon going round in this way. And this is the X dimension. This is the same total separation that we had before, which is actually equal to this here. These two circles are the same size. So there's the total energy, there's the space energy, and here's the X energy. And right now, these 2 sides are roughly the same. The moon's at a 45-degree angle, which is an equilibrium state that I'll show later when I show how the orbit is changed. It's reached pretty much after 4.5 billion years an equilibrium state where it has the lowest mass, and we'll be talking about mass, which is not involved here. I've got no time dimension shown here. A time dimension would be another dimension that I cannot show here. I've already got 3 dimensions. It would be the 4th dimension of the possible 9. So that I'm not showing any time dimension, so I'm not showing any relativistic effect that we described in the video on Einstein's special theory. So here, however, is the radius of the moon on the surface of a multi-dimensional energy sphere, which actually has more than 3 dimensions. It's on the surface, describing a circular orbit, which in space looks like a circle. It has a radius of about 237,000 miles. This is about 320 or 330 miles further out because of the kinetic energy, which is shown here. And the vector sum of these 2 is the total energy. This is the kinetic energy, that's the potential energy, defined somewhat similar to different from the way we define them ourselves. So we have to look at the meaning of potential and kinetic energy on another occasion. So this is very briefly what has happened, why it has happened, and how it happened will be described on another occasion. But thank you for watching the first of the gravity videos.